And I'd like to welcome John Jeremiah, Director of Traceable AI, looking at how new cloud native microservices API driven applications could put your security monitoring in kind of like this bog. Looking at 4 key areas need to focus and how to get started right now. And I believe John is bringing even a special guest on. So I will turn it over to John.
Hey, good morning, everybody. How's everybody doing? So let me dive in. And Sean, thank you. It was really fun. I enjoyed listening to Elle's presentation earlier, and it reminded me a lot of the things I used to do and experience when I was leading QA and as an IT director and as a developer of the conflict and the challenges between security and developers. And it's part of the reason I got to be real excited to be able to partner with the DevOps community and work with people like Gene Kim and John Willis and others to build this idea about how do developers and security and operations all work together. And in my career, I eventually started to work with startups like GitLab and now Traceable to really help evangelize and to help share the story about what we need to do and how we need to change as professionals to be more efficient. And so I approached these presentations not as a vendor so much, but more as a professional in the IT space who's done a variety of different roles from engineering to leading IT organizations and teams to really share what I think some of the things we need to do differently. And when I reflect on my experience in those roles and the experience I've had working with IT professionals around the world is we've all faced this amazing challenge. And the amazing challenge, let me see if I can advance my slide. Okay, I need to advance the slide. How do I do that? There we go. Is our business partners have had unbelievable expectations for us across, the years of wanting new technology and new solutions that would meet their needs, and they wanted them yesterday. They had business challenges and business issues, and as we went forward, the IT teams and the technology teams, they were able to respond. And I think, and I reflect back on what's happened in the most recent years as we look back. What's happened? We've seen the evolution of cloud and cloud technology with containers and the ability to build and deploy applications and to spin up and tear down servers without any real overhead or extra effort. You look at how we've adopted practices like Agile and DevOps in order to go faster and in order to break down the friction and the silos between teams. We've adopted and developed solutions that now we have, basically solutions running everywhere. How many cameras, how many smart devices, how many street lights are now all automated? And a lot of this has happened because of the technological changes of the way we build applications. We've developed new ways of constructing applications that make them scalable, resilient, and able for us to iterate faster and faster. And the technology under the covers of interfaces, programming APIs, application programming interfaces, and allowing us to build microservices and cloud native have really been at the core of an enabling approach and a process for us to develop and ship faster. However, and you can think of it in one way, the API is really the key to a lot of what's happened and where we're doing this. And if you look at, and how Gartner and Forrester and Harvard Business Review and across the board, the idea that APIs have really transformed how we work and how the economy works is happening on many levels, and it's really been at the core of it. Now, many times when I talk to people, API is a term that unless they're a developer, unless they're in the core of it, it's a little bit obtuse and it's maybe not specific. So, in the really simplest way of thinking about it, I like to illustrate, an API is really a very simple concept. we're used to these as children. And if you have children and Legos around the house, you step on these things, and the APIs on those building blocks are actually kind of hard when you're barefoot and you step on them. But that click when you put them together allows us to build and develop amazing things. I mean, really simple concept of these simple blocks with simple capabilities. But when you put them together, you can develop really quite amazing and elaborate structures that can do incredible things. So, from one really simple, really minor, and easy to understand interface, we're able to develop and deliver quite amazing, remarkable structures. And this is happening in other areas too. I mean, if you consider what happened over the last 50 or 60 years as we defined an interface as a way of managing moving goods and services. Today, global commerce is powered largely because of the fact that we can put all sorts of goods into a standardized, simple container with a common interface. And then we're able to move those somewhat without friction around the world. Although I think the current experience today where we're finding bottlenecks in the supply chain, that's another whole nother presentation. But the interfaces that we see in this have allowed that innovation as well, not to mention, other kinds of innovation that we see everywhere. And so the APIs is really at the heart of innovation. And it's allowed us to then to transform the way we build and architect applications. And when I was developing applications a few years ago, and it was more than 10, a lot of times the architecture we were building was more of this monolithic, custom, bespoke application with some sort of a user interface that people would enter data into it. There would be a whole set of business logic that would run, and then a database that would manage and store the data. And that whole thing was large, it was hard to manage, it was fragile. It led us into this idea that we had to do all of this building and all this testing of the entire thing before we could release anything, because one little part would break everything. We moved forward to this idea of building cloud native and applications composed around microservices, each which does a specific thing, where the microservice can live in an AWS cloud in EC2, or it can be running on premise or wherever it makes sense for the business. It can be written in different languages as long as they can communicate and work with each other, so that way the teams can use the most natural and efficient language for them to be productive. It unlocks amazing potential, especially when we start to think about microservices that aren't rigidly or connected to each other in a way that when one goes down, the whole system goes down. Not unlike my air travel yesterday, where a server outage took down 700 flights, which was a whole nother experience, which I don't like to. It was fun, not. But this idea has allowed us to really develop and to transform and to deliver amazing solutions. And what I'm showing here with this simple example is really an enormously simple example, because if you look at how modern applications look, take Amazon or Netflix, there are hundreds, no, there are thousands of different microservices working together to make this happen. Now, while there's enormous benefits to what we're talking about, there's also some very significant challenges that the dependence on APIs has introduced. Right? APIs expose and manage business logic as they connect with each other. They share context going back and forth. APIs have proliferated. I mean, when I talk to CTOs and security leaders, and I ask them for the inventory of all of their APIs, it's often a fun conversation, because A, they usually don't have it, and B, it's almost always changing, because there's shadow APIs that are being created. Developers are spinning up APIs to do testing and they forget about them. And for one reason or another, all of a sudden you're facing the potential of having external data exposed that you didn't think you were doing. And oh yeah, the APIs are always changing. And when you go into this and you think about the more specific API challenges that people have to deal with, developers and security alike, it really becomes, one where you have to understand, well, what are these APIs specifically doing, and do we know what they're doing and how they're doing it, and how they work with each other? As a security leader and security professionals, how do you know that your applications, where Forrester, or as Gartner, I think, suggested that API attacks in 2022 are going to be a main attack vector. How do you know that the APIs are secure and trusted? And when you think about as the business, how do you understand how they're being used and how they're being adopted and deployed? And so as we think about these things, it leads to some challenges, right? And we look at this, for example, that developers and IT teams and the operations as a service team, playing off of at the last presentation, is how do you understand, how do these different components communicate with each other? How do we understand the dependencies between them? How do we understand when one introduces a security vulnerability, how that could either propagate, or when one introduces a performance issue, how do we address that and deal with it from either a security perspective or from a performance perspective? Both of those are unique challenges. And then if we look at, how is it that we've adopted a way to monitor and to manage this and to deal with the situation, and you look at most developers' workstations, is we see this proliferation of dashboards where there's dashboard here, a dashboard there, all the different views to look at what's happening in our environment, which means that the analysts and the teams and the people that are trying to execute and deliver are now forced to context switch and think from this view to that view to understand how are things working. And then when developers are put on the spot to deal with the incident, to deal with the outage and the problem, where do they go? Well, now they have to go deep into a log to start to understand what's happening in a query. They're dependent on DBAs and others to help them troubleshoot and to figure out what's going on. It becomes incredibly difficult. And one last bit, and I don't know how many of you have done this recently, but how many of you have gone into the logs for a application or a service to try to understand what is actually happening to correlate then the security vulnerability or the issue that you are running into? Yet those incidents, when they occur, you're in the heat of the moment, and this becomes an incredibly challenging problem, especially when you reflect back on what it was like. What's it like when you think about an application like Amazon or Netflix with the kind of complexity we're talking about? It's a very real challenge. And so I want to bring this back to security, and I want to create and set the stage for, so what does this mean from a security perspective? How are APIs a unique security challenge? And I've I've drawn up a really simple example as a way to simply to illustrate how this is a problem and how we need to think about it. And if I can, slides advance. There we go. So, real simple example. Imagine a fictitious company, we'll call it API Zon. And they sell things and they have a shopping cart, and you can log in and find things in their inventory. And you can, these services all work together to make it happen. And the one thing that's going to be different in this example is when the APIs talk to each other, everything's going to be in the browser. Now, that's not the way it really works. You're not going to see it in the browser URL window, but for this example, I want to do it that way just to illustrate. So let's just take one example, and we're going to go to APIs on, and we're going to do a hacking example. It's really basic, and the exploits at checkout. And here, our shopping cart has a lovely 55-inch TV for about $800, and somebody has added a new parameter to the URL, a disk parameter. I think they're trying to apply a discount to that TV. This is a problem. If the microservice under the covers accepts an input with a parameter of discount, we might have a problem. We might have a real problem when someone decides to automate this and put a script behind it and start to order hundreds or thousands of TVs for $6.24 each. Incredibly hard problem to solve because a firewall won't detect that. A whole host of other ways of catching this are often blind to this kind of a vulnerability. Same scenario. I want to go look at my account details. I want to understand what my methods of payment are. I want to understand my PI, I want to update my address. And I go to my account lookup process. And now I can see my customer ID. Again, imagine the data breach that's possible when I set this up and I have a script iterate from 3321 to 22 and to 24 and on and on and on. Again, another kind of vulnerability that microservice that's responding to account lookup, it's a perfectly normal transaction from its perspective, but the pattern of usage and what's happening is where there's an anomaly and a problem. And these are problems and issues that are not new. I mean, these are problems and issues that, frankly, have been occurring in a number of different places around the world. Whether we're looking at, different countries with voter issues or user tracking or problems where insiders are able to access information, you look at this and you see, and I see this trend is continuing to occur. And the data and the research support that this is a very, very real and significant problem we have to be prepared to address. So in many ways, a lot of times organizations and security we're flying blind because we don't have the visibility into how to deal with and how to solve for API security. And this is really where I pivot and start to talk about ways to solve for this. And I think there's really a couple of different ways to solve for it. First off, you have to understand how an application is working and what it's doing at a lower level. Call it application observability or API observability. We have to be at a lower level to understand the inner workings of the application, and we have to apply technology to solve for this because remember the logs and all the dashboards and all the data flowing. It's something that people simply cannot do. And so if I were to summarize and to try to get into really what I think of 4 key steps that we have to adopt as professionals and we have to figure out how do we solve for is this. The first step really is truly having a system in place to where you have insight and visibility into the DNA of the application, the components, the elements of the microservices and how they're communicating, and the business context in which they're working together. That's got to be the first step in that process. The second step is really to look at a way to embrace the spirit of DevOps, the spirit of continuous delivery, of applying the practices of automation and machine learning in order to deploy and keep up with the speed of developers and the development teams who are deploying at the speed of the business. So this has to be at the core. It can't be the idea that we're going to introduce new gates and new phases to slow things down. We have to enable the whole team to move as fast as the team needs to move to meet the business needs. It's not a case in which we need to slow everyone down. We also then have to put into place the tools and the mechanisms to respond to and to deal with the issues and the incidents when they occur. It's one of these situations where having everyone swarm to a war room or a virtual war room to try to solve for this and to figure it out on the fly is not the time that you want to be, what you wanted to be doing. You want to have in the practices and processes built in, so that way when these API issues start to occur and someone's taking advantage of your implementation, you're able then to deal with that on the fly as it happens. And the last, I think, key part of how we need to try to solve for this and how we need to think about the solution of doing this is really it's about, and it's fun to follow people where our message is aligned, and there's an alignment with L's earlier presentation, is that we have to really approach this as a unified team that's solving how we deliver business value that's both secure and reliable. Too often, we've had these teams that operated in their own world with their own objectives, where developers wanted to go fast and ship and move things really fast, and their goal was developing at speed, and they adopted continuous integration and continuous delivery to go fast. And too often that meant that the security team was left off in another space where they weren't connected to what was happening, and they were forced in many ways to respond and to figure out, well, how do I understand what the new threats are? How do I deal with this? And they're always in this mode of reacting to this latest input of how do I do that, and they felt left out. And then the operations team, and I don't think it's operations as a service, but when I think of operations, I think of the professionals that are focused on trying to make sure that we're efficient and compliant and effective and available to meet the business needs. And in many ways, they're doing amazing amounts of work, but rarely do we see all of the furious paddling that's happening under the waters to make sure that everything is happening. However you solve for API security has to address the needs of all three of these key stakeholders. It can't be a situation in which, oh, we're going to solve this for one group and expect the other groups to go along. You have to bring everyone together. And so in the world of traceable, where we're trying to solve this and we're working on an approach to solve this, we have a point of view. And our perspective is that we can solve and address application API protection with an approach that starts with a perspective of understanding the inner workings of the application. We call it distributed tracing. It's a technique and a technology that's been around for decades as a way of managing application performance. But it's about how do we apply that technology and the capability to understand the inner workings of applications at the language level or at different levels of the application in order to not make it perform better, but in order to understand it from a security perspective. And then adding a robust machine learning algorithm and series of algorithms to understand that data, to infer both where are there anomalies and behaviors and practices that are things that we see in the data that are not right, all of a sudden creates the ability and the opportunity to bring teams together, to provide the deep visibility into how is an application both designed and implemented with what are all of the different APIs, what are the risks associated with those APIs, and how is the data normally flow, to being able to then detect and understand anomalies and issues within an application as it's running. And then because we're able to do that, we're also able to apply logic to determine, it says, look, if this user starts to process, if a user starts to go from one account to another, that's an anomaly, and we can then block that. So it's not as if we have to write rules to block a certain IP. We can think about blocking individual users based upon behavior and what they're doing. And then lastly, having this data and the insight in a place that is searchable and you can do analysis against it, you can start to understand what are the past and the previous attacks and previous threats we've seen that we've had to deal with. And so a little deeper dive into this. I think I've covered most of this here, but it's about truly understanding how users are performing and what users are doing inside of your application. How are the APIs working with each other? And then bringing that together in a way that allows organizations to focus on delivering and building and moving fast. And whether you're a security professional focusing on improving application and API security because you're managing and lowering the risk to the business, or you're a CTO or an engineering leader focusing on how do you go faster and also worrying about security and risk and performance of your applications. We're helping teams across the board solve that. One example uh, was what Greg at Hauser. Hauser didn't show up. He's a CTO at Hauser. Uh, didn't show up in that slide. But anyway, I mean, they've adopted and deployed Traceable, and one of the things that he talks about when he describes the value and what he sees is now he has this visibility so they can stay ahead of it and solve application and API security. And so that's pretty much the story. I've got some time, and Dan is with me. We can answer some questions. As we wrap up, there's a couple of things that are available. We worked with Alyssa Knight, who's a CISO and a hacker, and she actually has done a whole host of API hacks, and we have a book called that she worked with us on, The Price of Hubris, which is understanding the perils of overlooking API security. And she actually does a deep dive into describing how she's hacked APIs, and it's a really fascinating book when you look at that. And the other part of it is, this is one that we have a free trial, we have a free offering, which if you're interested, it's on our website. But I think that I wanted to at least make it a point that we would love to connect with you and talk to you about how API security is a growing challenge and a growing issue. And so we can book a meeting, and somebody from our engineering team or our security research team would love to talk and explore how we can help you improve your API security and your security posture overall. Sean, that's it for slides. I think I did okay on time.
Yeah, you're good. We got some time for questions, and I see Dan is raising hand. He wants to answer this question. So our first question for Dan is, how do you inventory the APIs you have in your organization?
Dan, do you want to talk?
Yeah, sure. Hi everyone. So I think John started talking about that. It's really important to know what is it that you have so that you can protect it. What we find as we talk with more and more organizations is you can't rely on developers to do open API documentation as consistently as we would like. And it's not developers' fault. They have a focus, what they need to get done. There's a lot going on, and that's usually the thing that comes later, right? If it does come. And so with organizations we talk to, we find that it gets behind, right? The documentation is there, but it's out of date, or it's just, what about shadow APIs that you don't even know, or developer doesn't even know they're using. And so having a system that is actually watching the traffic and learning from reality is really something that can eliminate that challenge and basically have it built up the inventory and track and update the inventory automatically. And that's kind of a little bit what John was alluding to when he showed that the slide of all of that. So
great,
great question.
Yeah. So there's another question. APIs become dangerous if they're not tested before deploying them, and users copy them around. So how would you, or users copy them from Stack Overflow, which I do Stack Overflow a lot. So how would you suggest or approach testing your APIs?
Yeah, no, that is absolutely, it's a great point. And we know that, part of why everything can move faster is because we're all learning from each other. And that's part of going to Stack Overflow and seeing what other folks have done. So not to discount that at all. I think that's actually a way that the community moves forward together and we learn from each other. But it is absolutely real, not just Stack Overflow, but anything. When you're using code that you didn't write, how do you know that it's secure? And there are tools that look at supply chain management for external third-party or OSS libraries. There is also this testing, and I think that whole shift left mentality is the right thing. It's not really about just testing earlier, it's about thinking security earlier. which means when you're about to copy that code or when you're about to point to some new library, what do you know about how secure it is, right? So we need to teach our developers, our QA, everyone who's involved in the SDLC process to be thinking security all throughout, not just saying, hey, it'll get caught at the end. And to that, there's different tools that help with testing early, but we also think that this feedback loop is super important, which is sometimes you don't know, even doing a static analysis on its code, if it's going to actually be a problem. These vulnerabilities in APIs that John was talking about, where the logic is right, it works the way that it's designed, but there's a break in the logic somewhere that you can't see by just looking at the code. We need to be able to see it in action live and have that feedback loop from production come back into the earlier stages to know, okay, in the production, this had a problem. How do we get back and fix that?
Great. Well, thank you so much. There's more questions, but what we're going to do is we're going to copy those over to the Slack channel. So now as everyone's going to virtually go out into the hall and surround John and Dan and ask other questions. So go say hi to them in the Slack channel. I want to thank you, John and Dan from Traceable, for the great conversation. APIs is API management is a thing that we're on our team trying to figure out how the best way to do it. So this is some great information here. I appreciate it.
Thanks so much, Sean. Thanks, everyone. Look forward to seeing you all in Slack and online. Take care, everyone.
Absolutely.
Thanks
Thank
all.
you.